Hi everyone, my name is Panos. I'm a co-founder of NetBeez, and I'm going to cover some technical details in this part of the presentation. I'm going to start by the high-level architecture of NetBeez. It consists of three parts. On the left-hand side, you can see the agents that connect to the server. Now the server is typical installation is a single OVA image that you install in your data center, or can be in the cloud also. That is dynamically can spin multiple processes to handle a different number of agents. So depending on how many agents you have, you can set the specifications, the provisioning of the memory, the hard disk space, and number of CPUs. And then, depending on that, of course, we're going to spin the number of processes necessary to handle the dozen or hundreds of agents you might have. For real-time data, we have an in-memory database that streams data to the dashboard and does real-time analytics. And of course, there is a persistent database that stores results as long as you want. You can have the option, actually, I'm going to show you later, how to choose how much data you want to store in your database and your hard disk space. And finally, of course, there is on the right-hand side, the dashboard. That's the interface between the user and the agents and all the backend. The user doesn't have to touch the agents once they are installed for upgrades or anything like that. Everything is handled automatically on the backend. That's also how you set alerts and you handle all the data received by the agents. And then we introduced recently integration with tools such as Slack, Splunk, PagerDuty. You can handle those with the dashboard again. And Stefan will demonstrate how this work and look like in the next session. Now the communication between the agents and the dashboard is done through an encrypted channel, so all your data is secure. Even if your dashboard is on the cloud, everything is encrypted, and there's only an outbound port open from the agent to the server. So security-wise, there's nothing open there for exploitation. And of course, the same for the user accessing the dashboard to the cloud or on-premise.
Did you say that was on a per source IP basis? So there's some kind of dynamically created ACL, or you have 443 open to the internet?
So yeah, you have to open it, right? You have to handle that if you want to have access from the outside in, right?
So it's not on a per client basis. It doesn't know the IPs of the end devices and only permit those in.
You can control that if you want, right? If you don't wanna make sure that nobody connects that's not supposed to, right? You can do that. But you can also secure that by using the necessary certificates from the server to the agent, right? So,
gotcha.
What happens when if the agent can't, for some reason, communicate with the Beez keeper if there's a partition event or something like that? Can it sort of continue to run tests and store those metrics locally, and then upload when possible?
Right, correct. So once, of course, for once it has to receive the tests from the dashboard, right? So once the tests are set on the Beez, then even if it loses communication, keeps running the tests as you described, caches them locally, and once the communication is established, it uploads the results. So you don't lose visibility even,
Yeah, cool. Yeah, that's awesome.
Yeah. And depending on, how big your disk space is on the agent, how many tests you're running, can go up to days, right? Depending on. Okay. Now the server, we offer both options. Of course, cloud, now everybody's moving to the cloud. And we can host for you the dashboard in the cloud, or you can host it if you want in your own AWS or whatever cloud provider you are using. The on-prem is still alive and well. Most of our customers actually prefer on-premise. For security purposes, they're going to have everything in-house, and for other reasons. So both options are available. And again, the on-prem installation is a single OVA. You download it, spin it up, and that's all you need to do. It comes pre-configured and doesn't need anything from the user perspective to set up. And the same with the agents, right? So we ship the agents pre-configured, you power them up, and they connect to the dashboard without any configuration. zero touch. Now, number of agents. So, of course, there has to be a limit somewhere there, right? We have two types of setups, right? If you up to 500 agents, all you need is a single OVA. I just described the setup. You download it, and these are the provision you need to do in order to support up to that number of agents, right? Now, for higher number of agents, I described earlier. I showed you the high-level architecture, how the scaled-out architecture looks like. In that case, you need to replicate the server part where the agents connect and store the data, and then in that case, you can go to higher numbers. The data that are stored in the persistent database can be controlled by the user. So you can see here, I give you an example of a data retention policy where you keep 6 months of raw data and 3 years of averages. And you see here that for 22 agents, it's around 400 gigabytes. And if you want to keep a year worth of raw data, you would need less than 1 terabyte of data, right? So again, hard disk is cheap these days, so we give you the ability here to store as much as you want to go back in time and pretty much and get averages, statistics, reporting, and so on and so forth.
Realistically, how far back are you seeing customers keep this data?
I haven't seen customers keeping more than a year. Very few more than that, right? Yeah. A few months, I think, is reasonable. If you haven't, I guess, discovered something for the last couple of months, probably it's okay. You don't care about too much. Right. But if you want to go back and run reports and stuff like that, then you need the data, right? But again, you can keep the report stored as well over periods of time. Now, the types of agents we support. Stefano covered that briefly, but we introduced a few new types to install agents in the last few months. The basic first line there is the wired fast Ethernet agent. That's the Raspberry Pi based one. And for gigi environments and when you're going to run higher bandwidth testing as well with HyperF, we offer a gigi agent. It's based on, again, a single board computer. It's called the Utilite standard platform. And on the Wi-Fi side, we also use the Raspberry Pi platform, and with a Wi-Fi dongle that actually, as of today, we support 802.11ac. And I'm going to show you some statistics later on how this works. For virtual environments, either cloud or your own data center, you can spin up your own agent if you want. Same idea, download the OVA and spin it up. And recently we introduced software agents, so you have your own Raspberry Pi with Debian Linux installed already. You can just run an apt-get command, install the package, and use it as an agent, right? We see many folks actually using the Debian package in home environments. So they have Raspberry Pis laying around, and they found a good use by monitoring their internet or the connectivity to Google and whatever, right? And finally, for the Raspberry Pi, you can also download an complete image from our website if you want to have everything pre-configured and you don't want to bother too much with your own Debian setup. Now, performance-wise, so we're fans of the Raspberry Pi for many reasons. Low cost allows you to deploy hundreds of agents at a price point that is reasonable, so you can cover hundreds of locations without breaking the bank. Also, great community, you have good support and availability, of course. And performance-wise, of course, has some limitations. The basic Raspberry Pi has a fast Ethernet connection, and the latest models, the Raspberry Pi 2 and 3, can almost saturate that 100 megabps. You can see here in the second column that you can get up to 95 megabps, right, if you run an iPerf test as server or client. We also tried to see if you use a gigabit USB-based interface to the Raspberry Pi. Of course, that's limited by the USB interface, right, because there's some limit there. I think it's 480 megabps that can give, USB 2 at least. And of course, that not even getting there, right? The Raspberry Pi 2 can give up to 100 megabps, and the Raspberry Pi 3 up to 220. And then we also tried different platforms for the gigabit version. Among others, the Odroid, you might have heard about it, Banana Pi, and then the one we adopted, the Utility standard. They have similar performance. The reason we chose the Utility standard is because of availability and support. And the performance-wise actually performs equally to the other platforms. And then on the Wi-Fi side, we also, when we introduced actually recently the 802.11ac card, we want to see what's the card, the SD card, the Wi-Fi card that gives good performance out there. We couldn't try all of them. We tested some cards from some well-known vendors. You see here a comparison between the iPerf bandwidth I could get from my laptop on the left-hand side in home environment, okay, around 180 megabps. And then I want to see how the Raspberry Pi itself and different dongles would perform compared to that. We also tried the Raspberry Pi 3 that has onboard Wi-Fi. That one, though, is only 2.4 gigahertz. The antenna is on board, so there are some limitations there on the performance can get. You can see here, the Raspberry Pi 3 could get only up to 20 megabps. And the SD card we chose, the USB card we chose for Wi-Fi is the Asus AC56, which can go up to 150 megabps for hyper bandwidth testing. This, of course, an AC card, but again, because it's plugged in on the USB, there are some limitations there. It cannot get up to maximum performance, right? Now, the types of tests you can run on our agents. This is common for all agents, of course, and we have two groups of agents, tests, I would say. These are the high-frequency ones, and we call them high-frequency because you can run them every few seconds if you want to. Of course, with ping, you can measure round-trip time, packet loss, and the typical scenario is that you run ping every few seconds, 5 or 10. DNS maybe every a minute or two. HTTP the same, and traceroute then every 2 or 3 minutes. That's typical setup customers have actually. So with DNS resolution against your local DNS server, or you can choose your own server you're gonna test the resolution against. With HTTP, it's a GET, so you can see how long it takes to fetch Google, Salesforce, Office 365. And traceroute finally, where you can record hop-by-hop information, path MTU, and used for routing and network performance analysis. Now, on the scheduled test that we are releasing right now, you can run the iPerf that we had already as an ad hoc basis, so you could run an iPerf between two agents or an agent and a server. Now you can run it periodically, TCP or UDP, and you can record all the historical data between bandwidth, packet loss, and jitter, depending what type of test you run. Also do multicast, QoS analysis. The speed test is the internet speed test. If you're familiar with Ookla, for example, right, when you run speedtest.net, when you go there and you try to troubleshoot, with many customers asking us, hey, I have an agent in that office location, and often they would call the user, ask them to go to speedtest.net, run the test, and then result back, and so on and so forth, right? And that's, of course, good for troubleshooting, but it's reactive. So it happens after the problem comes up. You have to call somebody. You don't have historical how things have evolved, and what's the baseline, more importantly, to know if things have changed and if it's an internet problem or a speed problem. So you have the historical now for this type of test, and You can be proactive about it and get alerted when something goes wrong before the user even picks up the phone to call the help desk. And finally, VoIP. The idea here is that you run between two agents a stream under different codecs. You measure jitter, packet loss, latency, and from that you derive the MOS. And you don't have to wait for users to place a call and complain about it and try to see what happened, right? You have the historical to see how things have evolved.
So with these scheduled tests, you have a REST API, yeah?
So right now you can only do them through the dashboard.
Okay.
We don't have it.
All right, because and this isn't necessarily specific to the scheduled tests, but I see a use case for this kind of testing in continuous integration environments. So when I set up a new network automation initiative within a company, I'm going to want it done in a pretty standardized way, and I don't want that to be sort of up to that point in time. I want it to be done consistently every single time, and I'd like to bake into that process. These are the tests that we run. These are the metrics that we gather every single time, so that I can have that baseline and then do a comparison. What would be really great is if I could call the NetBeez server programmatically, and it doesn't have to be synchronous, but relatively quickly after that request, get those metrics back so that I can do that comparison maybe before and after I change router config in an automated way. Yeah, configuration change, or configuration change in general, right? If you're gonna make a change, even like your ACL rules. Yeah, because this is where the rubber meets the road. I love where you guys are focusing because this is where the actual user experience is. You're putting yourself at that point and you're getting metrics there. And so having that ability to look at it in sort of real time programmatically would be super valuable. Right, yeah. Yeah, the API, so in terms of API right now, we have some integrations. I'm gonna cover it a little bit, but not anything open right now for general use. Yeah, cool. Thanks. Alrighty. Now the alerting that you can configure and receive from NetBeez, there are two types of alerts. On top, we see the up-down ones. So this is like when, that's the red one, right? You see here the Salesforce.com HTTP test is failing. And you can configure that to receive this alert, let's say, when after 5 consecutive HTTP tests fail or ping tests, right? So you can change that value. So let's say that you have a 5-second ping to Salesforce, and you expect an alert after 5 tests fail. In 25 seconds, you will receive notification that you cannot ping Salesforce.com anymore. On the performance side is when you try to capture performance degradation early on. And you can do that in two ways. One is by setting a limit. Let's say, again, you set a limit of 5% packet loss to Salesforce.com, and that's not a failure, but can be an early indication of something going wrong. And the other way is based on historical. So you create, you let the agents run for a few days or weeks. You create a baseline, and then when you deviate from that baseline by a certain amount, you can get notification, right? Because, of course, setting absolute values at each location is difficult because each location has different performance, different baselines. If you want to avoid that manual work, you can just say, hey, when my round trip time to Google goes above 3 times my historical average, notify me. Now, something that is still in beta, but people are using a lot, hopefully it's going to graduate soon to full production, is a console integrated on the dashboard. So each agent is a Linux box at the end of the day. And many customers were asking us since the beginning, right? Can we get SSH access to the agents? Can we use them if we want to log in and run something for troubleshooting? And you can do that. You can give you credentials. You can log in like any user. But on one hand, that can be inconvenient. You have to do it in 30 or 40 or 50 locations, 50 agents. And then you might not have open ports to SSH, and you want to do that when you really need it, right? So what we have integrated on the dashboard is a console. So in this case, we have this Pittsburgh Access agent, and you're going to run a port scan from that agent and see what's open around there. So you can type the command on the console there and get the results here, right?
again, very handy during troubleshooting purposes. Again, when you want to get quickly information that you don't have maybe running historical tests on, or it's a test we don't support because we don't support Nmap right now on the dashboard, but it's easy to get access to from this embedded console. And now, the integrations we offer, since the beginning, we're able to integrate with syslog, SMTP, and SNMP, so you could set your SNMP, your NetBeez alerts to your collector and have everything on a single view. And we just recently integrated with Slack, Splunk, PagerDuty Path Solutions. Anybody using Slack here? You are? Okay, great. So we have two types of integrations here, right? So the last three ones, Splunk, PagerDuty, and Path Solutions, it's one-way integration. So you can send alerts from NetBeez to these tools and then process them the way you want from that point forward. With Slack, it's two-way. So you can send your created channel, let's say NetBeez alerts, have your group on that channel, pay attention to it, and then not only you can you send alerts from NetBeez to Slack. Let's say you are on a troubleshooting session and you are chatting, the whole group is chatting around the problem. You can, if you want, send a command from Slack to NetBeez agent. Let's say you're going to ping really quickly Google from Austin. You can do it through Slack. The whole group can see the results there and get the results back, right? And Stefan will demonstrate that, how it looks like. So we have our own bot that you can call it and get this the information just described. And yeah, so with this, I think it's like the technology and features behind NetBeez. If you like what you saw, you can try it yourselves. You can sign up for a free instance. There are like 8 million Raspberry Pis out there right now, I think. So if you have one, you can just install a NetBeez agent on it, connect to our dashboard, and then from there you can use to monitor your office location, your parents' network, right? With Raspberry Pi 3, you can do also wireless, so you can do with NetBeez, right? So it's easy as it looks like here. Any questions?
With the Raspberry Pi installation on the unit that you guys ship, it's headless, right? So you just plug it in and it pulls DHCP and the agent's already running and then it registers in, right? Everything's all good. If you were to pop it into your own Raspberry Pi, it could still be headless, right? Once you've done that, now you unplug it, take it anywhere you want.
Yeah. Same story, yeah. It just, you just need to do the extra step of configuring yourself because, it's your own Raspberry Pi. If you get from us, you don't have to do that, right? Just power it up.
We get it from you, it has a nice NetBeez logo on it, right?
That too, right.
Ooh, sorry. 101 question. You're hosted or is this on-prem?
The trial version is, is hosted by us, right?
Yeah.
So it's on the cloud.
Okay, so if there's an on-prem version, then how does that configuration take place? Do you pass in a DHCP option?
So the server is on-prem.
Yeah.
You mean about like an enterprise installation, let's call it, right?
Right.
Not the free. Yeah. So in that case, we ask you to give us like the information about the server, like the IP and all the IP information.
Okay.
So we configure it, and then you just download it and spin it up,
Gotcha.
right? Or you can actually, even if you have an FQDN, that you
I was just about
want
to
to
ask.
assign.
That's better.
Yeah. If you can just spin it up, the server as DHCP, and then the agents know where to connect, right?
Basically, we have to tell you about where we've got it, and then you guys sort of stage it for us, and that's
Yeah.
that.
Yeah.
Plug it in. Okay, cool.
Yeah.